Okay, so we've been talking about Pythagoras, and I'm just going to show you another way that it can be used. Let's just imagine that we know that that distance is 5.1 centimeters, and we know that this distance here is, let's say, 2.2 centimeters. What's that? That's the right angle there. Well, because it's a right-angled triangle, A, B, C, C, we know that A squared plus B squared equals C squared if it's a right-angled triangle. And so, we know, in this case, that 2.2 squared, because that's A, plus B squared, oh, but B is X in this picture, isn't it, equals 5.1 squared. So 2.2 squared plus X squared, well, I've called it B here and I've called it X there, equals 5.1 squared. So X squared equals 5.1 squared minus 2.2 squared equals what? Well, I can't be bothered to work that out. Here's my calculator. Bonk. 5.1, where's squared? There. Minus 2.2 squared. Squared equals that. Equals 21 point, forgotten already, 17. So X squared is 21.17. So X equals the square root of 21.17 equals, well, let's figure that out. Square root. You see, I've already got the number up there already. Square root comes out to be this, 4.6 more or less. 4.6. So, just to recap, we had our right-angled triangle here. There it is. We knew 5.1, 2.2. We didn't know that, so I called it X, and we used Pythagoras' theorem in reverse. That's a right angle. In reverse, so to speak, to get 4.6. So now the full thing here is 4.6, 2.2, and 5.1. It's as well to check. Watch how I check it there. I know that A squared plus B squared equals C squared if everything's okay. If everything's okay. So let's just have a look at it. What is A squared plus B squared? Well, what's A squared? That's 2.2. Oops, 2.2 times 2.2. Yeah. 2 2s are 4, 4, 4, 4, 4, 8, 4.84. What's this one? 4.6 squared. Let's do that. 4.6, 4.6 squared. 6 6 is 36. Oops, that should be a 6. 3 to carry. 24, 25, 26, 27. 24 down 2 to carry. 16, 17, 18. 6. 1 down 1 to carry. 1 down 1 to carry. 21.16. So, let's go through this. 4.6 and 2.2 squared. We need 4.6 squared because it's A squared plus B squared, and we've got the squares here, so we just add those together. 21.16 for one of the sides. 4.84. 6 and 4 is 10. 8, 9, 10, down 1 to carry. 4, 5, 6. 2. It's too big. Why is it too big? Ah, I thought it was 5 exactly, and I was expecting that to be 25. But look, it's 5.1. We've got these two guys here because we've added those two squares there, and we come up to be 26.0. I'll pinch in a little bit. Here we go. So look, we've got that squared plus that squared equals 26. So we better work out 5.1 squared and see what we get. We better get 26 or something close to it. 5.1 times 5.1. 5 ones are 5. 25. That turns out to be 1062. 26.01. All right. Now look how accurately they are. So we expect 26.00 because that was A squared plus B squared, yeah? Because that 21.16 was from here, 4.6 squared. write it in. 4.6. Oops, 4.6 squared was that, and that was the other one, wasn't it? That was the other side there, 2.2. 2.2 squared is 4.84. Add them together, you get 26, and we should get c squared. So they should be identical, but you see they're not quite identical because, well, it's not exactly 5.1. Let's go back to the calculator. The calculator is showing not the figure I was expecting it to show. Oh, the 5.1 was correct. It's the x that I calculated that wasn't quite right. Look, I've got 4.6 down for it, but the real answer is 4.60108. So look, I just truncated it at this point here. And that's why we've got a very, very slight, a very, very tiny, tiny round off error here. But that's the kind of thing that happens when you use fixed precision arithmetic. Right, I'm going to stop there. Stop.